Welcome back for the second part of our laser scattergun or shotgun tutorial. So we left off last with the effects working. So when we switch to it, it makes a sound, we get our light, and everything kind of puffs out. So of course you could play around with the positioning of these things, but let's move on to kind of actually the exciting part, getting the Raycasts to work. So the Raycasts are going to emit from the two barrels, these 2 points right here, the left barrel shot spawn and the right barrel shot spawn, which we have attached as this barrel's array list. So the idea is that we're going to spawn a bunch of Raycasts out of both barrels. So let's go to the script to achieve this. And that's going to happen inside of Fire 1. Now, to refresh ourselves on a few things that we're going to need, we are going to interact with the barrels variable, because that's where our barrels are stored. And then also the number of pellets variable is going to play a major role here, as well as the aim down sights bonus. So we're going to also use that as well. So let's go and find our Fire 1. So we play our sound effect, we trigger the muzzle flash, we set the cooldown. Now what we're ready to do is go through and spawn all of our Raycasts. But we could do a few computations beforehand. So let's create a loop here. I don't know if I want to use I. I'll use B for barrel. B is less than barrels dot length. So we're looping through each barrel. And since this is going to be a long method, I'm kind of putting some of my comments here, so that I know what all these closing curly braces are. All right, so we're going to loop through all of our barrels. Now we want to get a variable to kind of help out with this. So we're going to create a vector 3 called shot direction. And that's going to come from barrels bracket B, the current barrel that we're working with, transform dot forward. So that's going to get the forward direction from that barrel. So essentially it's going to come out of two separate barrels, which is ideally what we want. We don't want it all just coming from the center of the weapon. That would feel a little disappointing if the players discover that that's how that works. And I think we can also calculate my aim down sights bonus. So we could call this aim down sights modifier. And that's going to be equal to that bonus that we had set earlier. So if aim down sights ratio is greater than, so if we're 90% of the way aimed down sights, then we're going to use a ternary if operator. And we need to remember what that variable is called. Pellet spread ADS bonus. Some of these variables, I need to just get a whiteboard with a list. Pellet spread ADS bonus. Otherwise, it's 1. And so this will be a multiplier onto the spread. Then we're going to loop through and spawn a raycast for each, air quotes, pellet, because this weapon is supposed to hit instantaneously. In FPS game design, this is known as a hit scan weapon, meaning it hits its target instantly. There is no projectile. It's just when you pull the trigger, it calculates what got hit. And many FPSs with bullet type weapons will use this type of system. So now we're going to loop through all of the pellets. I'll just use I this time. So first thing we need to do is calculate the spread. Oops, let me fix my for loop here. So we want to calculate the random spread. And, well, let's start with taking floats. Spread angle modified equals spread. We had pellets spread angle times the ADS modifier. So we're applying the ADS bonus to that. So if we are aiming down sights, we receive maybe a 50%. This will be 0.5. And so if we're spreading at 5 degrees, then we're only going to spread up to 2 degrees. All right, now this next part is a little bit ugly. We're going to use a quaternion called spread. I think I did. I think I used spread angle, so I can call it spread angle. And, well, this is actually, yeah, let's call it spread. And this will be a quaternion dot Euler, open parentheses. Now, this is where the computation gets a little ugly. So we want to spread the attack up and down, which means that's going to be a rotation around the right axis, and we want to spread left and right, which is a rotation around the up axis. So we're going to take shot direction dot transform dot up, because shot direction. Oh, we probably just need to go to barrels B, actually. So we're accessing what the barrel considers to be up. So like if you're looking in a direction, it'll still spread correctly. Times random dot range negative spread angle to positive spread angle. Now that's not it though. So we want to then, after this call to quaternion, well, still inside the call to quaternion Euler, we're going to put a plus sign, press enter, and do this again. But instead of rotating on up, we're going to rotate on right. And so this calculates, this essentially creates a random rotation for up. This makes us twist left and right because we're using the up axis as our rotation axis. And this makes us rotate the shots up and down because we're rotating along the right handle. So this is really the important part that makes a weapon spread. And it stinks that it is such an ugly command, but that's how you get shot spread on a raycast. So then we actually apply that rotation. So we'll say vector 3, pellet direction, equals spread times the shot direction. And actually, for the sake of clarity, we could just move this, because I only use this here. And then we could take this out. Sorry, I'm refactoring my code as I'm writing it, basically. So the idea is that we apply the spread multiplier. This is some kind of rotation, and we apply that rotation to what the barrel sees as forward. Then we actually make the raycast. We've done raycast before for our U's, so this shouldn't be anything too terribly new. So we'll say raycast hit is the data type. Usually you just call it hit. Then if physics.raycast from the barrels at position B dot transform dot position. So basically the barrel itself using pellet direction, using out hit, and we could put a distance if we wanted to. So if you want to have a max distance, you could throw a comma here. You could play around with that. It just prevents it from being an infinitely ranged weapon. We could still calculate hit damage fall off when we start putting enemies in, so distance isn't going to play a big role. We could just do damage fall off after a certain distance for the shotgun. Alright, so this is if it hits something. And that's honestly anything but Skybox. We would spawn a spark, but we don't have that yet. Spawn hit effects, prefab. Don't have it, we will get it in a second. But for debug purposes, we could draw the ray. And so this will allow us to see if it's working very quickly. So debug.drawRay. And we're going to draw the ray. Basically, it's similar to what we had here. Barrels at B.transform.position, comma, pellet direction, times the distance of the hit. And again, this is kind of optional, but how far do we draw this ray? We draw it up to where it hits something. Then we specify the color. And then this is how long it will hang around. So maybe like 1 second. We could up that if we wanted to. So if it didn't hit something, we could just do the same thing. Just draw it in green. And we don't have a hit distance, so we would just pick a distance of like 100 or something. And so this will allow us to visualize our raycast. So this is going to be kind of the screen that we're going to jump back to if you have any problems. So that you might want to screenshot this if you're still typing it. So we're going to save it, and we're going to test it. So we jump back to Unity. Now, when we hit play, we're not going to see it at first. So if we shoot our shotgun, we really can't tell it's doing anything. But if we push escape and turn on the gizmos in the top right, amongst everything else, we can see this. And you can see if you shoot it close enough that it is emitting from both barrels. And there's also going to be probably an unpleasant glitch of the fact that we can shoot through stuff. Like if we go right up next to the wall, because it's emitting from the front of the barrel, it's actually being able to pass through the wall. So we will need to fix that. But it is spawning shots out of both barrels, and both barrels are kind of spreading if we zoom in. So if we shoot enough times, we can see kind of the range that we get from here. If we zoom in, it creates a much smaller range. You know, further back we go, the more pronounced it will become. So we can see that this aim down sights behavior bonus is in fact working. So you can up the duration of the raycast if you wanted to see those for a little bit longer. But otherwise, that seems pretty effective. So I'm going to turn that thing off. Okay, so now the main thing for us to do, we could leave these draws on if we want, is we're going to have to make the prefab of the hit effect. And that's not going to be too hard. We could really just duplicate the old one from the blaster and do something similar. So if I go back and edit the prefab for my shotgun. Oh, well, I guess I'm fixing the barrels right now. So fixing these barrels, I would probably select them both using Shift and drag them both back pretty far. This will ultimately make it so that we're not shooting through the wall. And if you want to test that, you can go back to our code and re-enable the draw. And so now if I go shove my face into a wall, really doesn't affect the behavior of the shotgun at all, except for when I go up to the wall, it's no longer shooting through it. And so that's more of what we wanted instead. All right, so let's begin by duplicating our spark for the blaster. I think that's a good place to start. So I'm going to take this blaster spark, single left click it, hit Control D, it duplicates it, and I'm going to rename this from blaster spark to shotgun spark. And I'm going to open that up. So I don't want the green. I actually want the blue effect. And I want way fewer particles. So I really only want a few, so I'm going to set that down to 4. And another concern I have is that sometimes it spawns a little too forward. So what I'm going to try to do, well, we'll test it first before we really play with that. Now, I do want this to come out at a little less speed. So I am going to adjust this start speed, which it does appear to be a slight typo, to make it 1 to 2, or maybe like 1 to 2.5, so it doesn't kind of blast out as far. And I suppose I probably should clean this thing up, make it 2 to 3. Maybe 1.8. All right, so that's going to be my spark. I could play around with that some more. I could maybe shorten the lifetime since this thing does. We don't need them around that as long. So we're shortening the lifetime to 1.5. So if we go back to the weapon, and now we can attach the hit effect prefab. So we take our shotgun spark and put it into hit effect prefab. And then we just have to update our code to be able to interact with that. So we just need to spawn and destroy our hit effect. So game object spark equals instantiate hit effect prefab at hit dot point. So this is where the hit occurred. And to be fancy, we will do quaternion dot look rotation hit dot normal. So the normal to the surface. If you're not familiar with the normal, it's basically, if you have a surface, it's the vector that's perpendicular to the surface pointing away from the surface. So if you hit like a sloped thing, it will come out perpendicular to the thing. Quick diagram is, if you have a sloped wall like this, and even if my shotgun is right here and I shoot it and it hits right there, the normal is the perpendicular line. So this blue line is the normal. It's the perpendicular to the surface. And so we're going to make the hit effects puff out of the thing that got hit. And then we want to destroy it. Pretty simple. Destroy spark, and then we can specify a time to delay for how long we should wait until we destroy it. So we can save that, go back to Unity, and now we can test out our weapon. Oh, I still have my gizmos on. And you can see that it creates a lot of little particles whenever it hits things. And it is actually kicking out a particle at each location. So it is creating 12 of these things every time we shoot. As kind of hard as that might be to believe. I mean, some of them hit in very similar positions, so they stack up pretty quickly. And it works pretty well. We hit things, it bounces out of the surface. So notice how I'm like kind of slanting, it's coming out at the normal. So we turn off our gizmos, and we can comment out the drawing of the ray just so we don't have that there. And that's about it. So now we have a successful shotgun-esque weapon, or ScatterLaser, as I'm calling it. If we think it shoots too fast, we can always just nerf its speed, but we won't really get a chance to play with that until we get to actually putting enemies into the game. So next up, we're going to do a rocket launcher that has an alternate fire mode as a grenade launcher. And so that'll be really cool because we'll get to do an explosion effect, and then we'll also get to look at how do you make something bounce around, or do you just make the rocket explode on impact. And so that'll be kind of a cool weapon. So that'll probably take about 2 videos. And then after we do that, we're going to do a video to put together a heads-up display, which has an ammo count, our health, and then we'll actually start rigging up ammo with our weapons. And so then that will conclude our chapter. So thanks for watching, and I hope to see you in the next video where we make our 3rd and final weapon.